Great to see all of your smiling faces here on a wonderful Wednesday afternoon. I know there's a whole lot of stuff going on. We try not to take up too much of your time. You all know me. I'm Ruben Cash. I am the environmental coordinator for Skagway Traditional Council. With us on the phone is Barclay Sive, who works for the Air Resource Division for the Park Service in Colorado. He's been our project partner and mentor and all-around awesome guy. He understands as much about air quality in Skagway as anyone you could imagine. He's on this portal every day looking at our data. Just really been a wonderful partner and resource and friend to the program. We're just really happy to have him join us this afternoon. So a little bit of an icebreaker. You guys know me. I'm the salmon guy. I'm going to make you stand up a little bit. What's the best salmon? So we're going to start, and if this is your favorite salmon, I want you to stand up, okay? So what do we think about the chum salmon? Anybody got chum salmon is the best salmon? All right, maybe not. Maybe how about the sockeye salmon? Is that the best salmon? Oh, we got some sockeye fans in here. All right. Anybody a fan of the king salmon? We like king salmon. No, not so much a fan of the king salmon. I mean, they get a little big. It's kind of like halibut. You don't want to get the really big ones. Yeah, how about a coho? How about that silver salmon? Anybody a fan of the silver? Yeah, hey, we got some silver salmon fans. And then the stinky pink. Yeah, we got a stinky pink fan in here. Well, you're all wrong. It's grilled salmon. All right, so that's the best salmon, is the type that you stick on the grill and then eat it later. Okay, so most of the time when I'm talking to folks, I'm talking to people that haven't been to Skagway. And so I like to include this graphic mainly so that I get your attention off of me and onto the screen so you don't see how much nerves I have. But this little zoom in kind of provides context for anyone who's never really been here. And I've left it in here because it really illustrates how isolated from industrial centers and typical pollution sources that we are here in Skagway. You wouldn't immediately think that this tiny little village would need air quality monitoring, right? But those of us who live here know that there's certainly reasons to keep tabs on the air that we breathe. And there's definitely more reasons than one. Here's a graphic that you've probably never seen. I have took this from data from the skagway.org arrival statistics page. Just to basically visualize this increase in cruise ship passengers over the last 40 years. So you can see there's been a pretty big increase since 1983, where we've got 48,000 people showed up back then in the 80s. And it seems to be accelerating since the pandemic. Over 1 million cruise ship passengers, not counting those that arrived by road, by air, and by boat. And the last statistic that I heard was close to 2 million total visitors back in 2024. Is that about right? So that's a lot of bodies in a small, little isolated community. And especially when you consider the footprint of Skagway. You know, we're 4 blocks wide by 22 blocks long. It's a really small area to consistently have 14,000 people. So during the summer, it's all about moving people around so they don't all end up on Broadway. We've seen it when the rockfall happens and you can't get the train up the pass. You know, everybody spills out onto the streets. Or like today, there was a power outage. So I'm sure some of the things that normally would get people out and about, they weren't necessarily functioning. So you have this spill out on the street. So this people moving infrastructure generates plenty of revenue. It's really good for the town, but it also can generate this potential pollution sources. So we probably don't need to go over this, right? We all know what the potential pollution sources are in town, right? If there were one word to describe a pollution source, what would that be? Exhaust, yeah. Any other stabs?
Smoke, dust.
Smoke, dust, yeah, combustion, essentially. Anytime you're burning, you're starting that chemical process, you're going to be producing things, you know, you don't, nothing ever goes away, right? It turns into something. So as you're combusting something, you're creating aerosols, be that gas engine, be that your wood stove, your Toyo stove. Anytime that you're combusting, you're creating particulates that can go into the air. And then there's also, of course, what we've experienced most recently, which is long-range transport of wildfire smoke from areas very, very far away. And this is one of the reasons we originally wanted to establish this array, to act as kind of a warning system for those in the community who suffer from respiratory issues or cardiovascular issues, particularly when it comes to wildfire smoke. Like it or not, the prevalence of wildfire is increasing, and that's shown by this graph that was derived from NOAA data and census data throughout the United States. And it describes since 2006, the average number of days that a person's county will be completely covered in smoke. You can see there's kind of this pre-2020 mean. And then in 2020, things really started to accelerate on a national level. And I've witnessed this increase in my home state of Washington, and I'm sure that you folks have seen it here. And actually, that was one of the questions that I wanted to ask you. Have you noticed over the years that during the summertime, we see more and more wildfire smoke? Yeah, so the data definitely agree with that. And a lot of this is weighted to the East Coast, because I think the East Coast has been experiencing more and more of these influxes of the long range transport of fires out of Canada or in the interior of the United States. So that's been my colloquial observation, and it is supported by the data. So we've been studying it for a long time. You guys is everybody familiar with some of the studies that have been done here in Skagway in terms of air pollution? So I probably don't need to go too much into depth with this. So the city and the tribe both kind of independently developed these fine particulate matter studies back in 2004 to 2005. We basically found that we don't violate the national ambient air quality standards, but you do notice that there is a marked increase during the summertime. We're starting here in January, going all the way to December. That base kind of bumps up. And yeah, the only time that we really violate the NAAQS, those national ambient air quality standards, is during wildfire smoke events. But you do have all these other elevated events that are happening. The Park Service, of course, has been looking at this for the last 3 decades, focusing on nitrogen species, using these depositional samplers and some fancy ion something. I can't remember the specific term. I'm so sorry I butchered that, but and also the arboreal lichen plot study. And what they found was that the sites that were closest to the cruise ship moorages had the highest levels of nitrogen. And then, of course, we had our own PM 2.5 study between 2020 and 2023, which included 2 years of that summertime data without the influence of any of the tourism season, and millions of visitors, the attendant transportation infrastructure that comes along with that. Then we had kind of this, I call it the 3/4 fry, when we were at about 3/4 capacity, and then the full year of 2023. Really, really cool data set. The report was finally released. I finally got around to it. Ruben the Slacker back in September of last year. So that's available on the STC website for anybody who wants to peruse it. And so these are new graphics that come from that study. And we established that basically community contribution to PM 2.5 is less than cruise season contribution. You can see that in these bins. There's 4 bins broken up into the years. These 2 years were without any sort of, that was pandemic years. And then on the far side, you can see that was when we started to get that influence. And there's definitely a difference between the two. We also found out that the particulates were positively correlated to the number of ships in port. And I think this graphic is the best description of this. So on the upright, we've got our mean 24-hour average PM 2.5 levels. And on the bottom, we've got months. Those are the bins. So we've got May, June, July, August, and September. And then the 2 different bars are months without ships and then months with ships over the 4-year study. So you can see that there's definitely a difference between the two. Again, we don't not violate any of the national ambient air quality standards, but we do see an increase. And so just because it's not unhealthy for everybody doesn't mean that it's healthy for everybody. There are some people who maybe, I mean, if you're up to 11 micrograms in the middle of July, some people aren't going to be able to tolerate that as well as other people. And so it really behooves us to be able to monitor this. You're not going to notice that difference just by visually looking at it. Data really, really helps when you're concerned about your health and you have some of these sensitive issues. So these are all great studies, right? But there's gaps in the data, and all of these efforts were essentially conducted in isolation. So as many of us have come to understand, there's a synergy in collaboration that far outperforms the same efforts done separately. And so it makes sense for us to combine our resources and work together. And the park and the city started this back in the early 2020s by jointly deploying purple air monitors on park and city land. And then the tribe and the park began exploring air quality intersectionality shortly after. And so when the EPA announced its Air Quality Monitoring for Communities grant, in 2022, we were poised to submit a co-authored proposal. Barclay and I worked on this for, it must have been a month and a half. I was doing the final bits down in Washington State while I recovered from oral surgery. So it was a little bit of a fever dream for me, remembering back to when we were setting all this stuff up. And it's amazing that it's so many years later, and we're at the end of this first full year run of gathering data for the community. So it's really, really very exciting. So we were one of 4 projects in the state of Alaska, and it's really cool because the Upper Lynn Canal was really well represented in this grant. Only 4 projects were selected for the whole state, and Skagway Traditional Council and Chilkoot Indian Association both got really big chunks of money to start studying this. And CIA is looking at more of the glacial till that comes down from the Chilkat Valley. I didn't understand that was a big impact, but they've been measuring this now, and sure enough, you can see I think it's more the PM10 that shows it. But they have their purple air monitors set up in an array, and they've witnessed now several events coming through, and they've been able to warn the community about this. So it's kind of in the same vein. It's air monitoring for communities. So we're presenting these data so that you guys have them, so you can make those decisions for yourself. So for the benefit of Baron more than anything, our new employee, I'm going to go through the array. It's kind of hard to see on this map just because it was made in GIS and it's made to be viewed on a much smaller screen. But as we step through this, you'll be able to see the symbols a little bit better. So we started with these purple air monitors that the city and the park set up. And what this does is it really just provides the framework for this network. The real estate's in short supply in Skagway. We have to put these things somewhere. And boy, if we can put them in an ideal and representative spot, that's even better. That's not always the case. I mean, you gotta work with what you have. So, but this was a really nice thing to have this already set up. A lot of them already had little Wi-Fi portals ready to go, powered, supplied to it. So we were able to kind of piggyback off of this to get the network up and running. Purple airs only have about a 2 to 3, maybe 4-year lifespan if you're really lucky before they start to poop out. So many of these were at the end of their useful life when we started up the array. So we went ahead and we replaced many of these with these 2B Technologies personal air monitors. And these have the same exact plan tower sensor. That's this little guy right here, plan tower sensor that the purple air units have. But then they also add these other 3 analytes. We're looking at carbon monoxide, carbon dioxide, and nitrogen dioxide, so that we can expand what we're actually looking at. They're super cool. They're self-contained. They've got a little cellular card, so they beam data off to the 2B portal. I would say they work flawlessly, but like with anything electronic, there are going to be issues no matter what you do, and you put them in harsh conditions, and suddenly you have a whole new slate of problems. So I will say that they are an elegant system, and when they work great. We did add 2 new ones since the last time, because I know several of you were here the last time. The radio tower up here, the purple air kind of kicked the bucket. Same thing at the public safety building. So this just happened at the beginning of this year. Is that right? Did we replace them this year, or was it late last year? It was late last year, pretty relatively recently. So whereas we had 5 deployed before, now we've got 7 of these deployed. So now up at the radio tower, we're really excited about the radio tower because everything else is kind of down at valley level. So now we've got something that's a little bit further up, so that we're catching things that are happening higher elevation. We were able to see this also when the wildfire smoke came through. I think the radio tower was the first one to pop off because it is kind of higher atmospheric. So really cool units. There is one sitting right over there. That's our spare PAM. So you guys are welcome to go take a look at that when we're all done talking. And yeah, we're just excited to have these in place of those purple airs. We also have these 2 AQ lights, also from 2B Technologies, and they have the same exact little printed circuit board and sensor suite that the PAMs do. So you can see that represented in that little square, got the PM, CO, CO2, and NO2. But then they add this really nice little Model 108 ozone analyzer. This is a federal equivalency method module that's looking much closer tethered to reality ozone data. These guys just got to experience taking one of these things all the way apart and replacing the O3 lamp in it. And I think after that, they're going to be experts on the AQ light units. We have them co-located with these Quant AQ modular PM units. So the plan towers only look at PM 2.5. So we're now expanding the size fractions that we can analyze from PM1 all the way up to PM10. The big heavy hitter sitting right behind the screen right here. This is our AQ Sync, also this is all 2B Technologies stuff except for the Quant AQs. And so it's looking at the whole suite of PM. It's looking at that CO. It's got a really nice, instead of just a sensor puck, it's got a CO2 module built into it. It's got that 108 ozone analyzer, that FEM, Federal Equivalency Method analyzer for ozone. And it's also got an FEM NOx line. So we're looking at NO, NO2, and total NOxes in this machine. So we know that the AQ Sync is as long as we maintain the equipment, we know it's very, very closely tethered to reality. And what we did in the very beginning is we co-located all the rest of these machines to it and let them sit there and spool for a little while and spit out data. And then the smart guys over at the Park Service and ARS took a look at, they compared the two, and you can set a slope and an offset to bring all of those things in close and synchronize them with the AQ Sync, which we know is very close to reality. So it's a very aptly named unit. It synchronizes everything else, and it kind of acts as the brain for the rest of the system. And then finally, we have these 3 all-in-one meteorological stations so that we can look at MET data, at atmospheric stuff. Can anybody think of why we would want to know what the rainfall and the wind speed and the relative humidity is doing? Why is that important for air quality? Anybody got a stab? Take a step.
Rain can probably move anything that matter around. Rain might help it settle.
So it's going to affect some of the readings. So if we see something that doesn't quite make sense, if we don't have these MET data tied to it, then we're not going to have that piece of the puzzle. So having real-time MET data tied to real-time aerosol data is really important when it comes to analysis. And I'll show you that a little bit later from this most recent event. It's a reason to thank the Skagway winds for sure, one another. And so it's all being beamed out, right? It goes to the 2B portal, it goes to the Purple Air portal, it goes to the Quant AQ portal. And then our partners at Air Resource Specialists in Fort Collins, Colorado, pull all those data together, and they send it through an algorithm that automatically screens for error. And then they gather it all together and they put it out to this. This is Skagway's public facing portal. This is where all the fun happens. All the magic happens, mostly card tricks. And so let's go. Does anybody want to take a walk through? Maybe do we have you guys all been using this array? Have you guys all been watching it? So you understand how it works. So I probably don't need to go too in depth into how it works, but it's basically going to show you all your stations. Looks like we currently have a station that is coming up over 50 on the AQI. And we'll also talk about that in just a moment. There is some news on that front. But yeah, so these station icons are going to light up corresponding to the PM air quality index. And an air quality index is just a much more digestible way to communicate what's happening. If I tell you there's 25 micrograms of PM 2.5, you're going to look at me like, huh? Doesn't really mean a whole lot to people. So it's color coded. It's instead of having some strange benchmarks like a 35, you know that you can go to 0 to 49 and you're good. 50 to 99 is moderate, and so on. It's easier to know where you are, and then on a personal level, you can gauge, like, I know on a AQI over 50, I start to feel this way, or I know that I'm okay over an AQ up to even 150. So you kind of got to do your homework so that you know where you sit on the AQI, what's going to start affecting you, but it does give it to you in a very digestible sense. So it's also nice. We've got some links up here. So if you have a question like, why do we even care about ozone? You can click on that. It'll take you to the EPA site, which will give you a rundown on what are the limits, what are the effects, how is it created. Really, really good resources up there. Over here, we've got our wonderful little weather banner, so you can tell what the weather is right now at that moment. You can select your sites and your parameters. I think you can grab up to 5 at a time. And then you can choose your date range and the number of days to chart. You can chart up to 14. And if you're super nerdy, you can tick this little export data button. It'll download a CSV. You can take that home, load it into your favorite spreadsheet program, and have a legitimately ridiculous Saturday night. Very, very cool stuff. So we have certainly, let's get back to where we're supposed to be. And is that here? Here it is. There we go. Sorry, guys. So challenges. Boy, the best laid plans are bound to run into some roadblocks, and we've certainly faced some challenges along this journey. And the folks that are sitting in the back there can attest to this. They, Colton and Eric, have been so instrumental in getting this stuff maintained, getting all the filters changed out, and just kind of head scratching over how to go about the regular things that we need to do to keep this maintained. So one of the challenges is just the complexity of the instruments. Consumer grade products, they're typically self-contained. And so any user replaceable parts are made accessible without having to like crack into the guts of the unit. They'll actually probably void your warranty if you undo those screws and get to where you see a printed circuit board. Not so much with these monitors. So to change filters and scrubbers and Nafion tubing, we have to dive directly into a sea of silicone tubing, printed circuit boards, block terminals, wires, and optical benches. It's tedious and it's intimidating, but we thankfully have the good folks at 2B to help us out along the way. Actually, our project has sparked a number of technical notes that are outlining how to perform specific field repairs, and we're definitely getting better at it. Again, like I said, I had these guys take apart an optical bench today and replace an O3 lamp, which basically was just completely dismantling the entire 108 ozone analyzer down to the PCB, the printed circuit board, and they did fantastic. Wide-eyed at first, because it's, again, like you look inside this thing and you're like, oh my God, like, what's going to happen if I unplug this thing, but they did a really great job, and I'm hoping that they have a much better understanding now, and it's less intimidating once you go through that process. Oh, another challenge is the weather. Southeast Alaska, we experience harsh conditions, right? And cold and wind and the rain, because these can all have a negative effect on this stuff. So up here, on this one, you can see our sink incurred some damage when we tried to do our first quarterly maintenance during a rain. It wasn't a rainstorm, but there was precipitation falling, and the door of the AQ sink opens up nice and wide, and it's just everything is right there. There's no protection around it. So we quickly found out that we need to wait until there's a rain-free day in order to open up these boxes so that we don't do the damage like we see here. What happened is a drop of rain dropped down and completed a circuit between two of these that it shouldn't have. And you can see these little tendrils of burns that kind of went all throughout the PCB and rendered it not completely useless, but many of the functions were no longer working after that point. So that was fun. We replaced the unit and it's been chugging along ever since. And now we know, don't work in the rain. And so it can't work in the rain. Then there's also the wind. Last winter, a windstorm ripped our AQ light straight off of its tripod, and you can see that represented here. This is a pretty stout piece of metal, and Eric and Colton found it just face down in the snow. We unfortunately didn't get a picture of it because it would have been perfect for this presentation. But we decided not to stage a new one because that probably would have been irresponsible. Anyhow, they were able to repair the tripod. They did a really awesome job reinforcing the pallet, and the thing is just rock solid now, and it's survived several big windstorms since. But unfortunately, the main circuit board of this unit was irreparably damaged, and you can see a little bit of that here. You can see some of the crack on the little LCD screen. Here you can see more of that, and then this right here is a really important part of this because the only readout that we have on the AQ lights is this little LCD screen, and you can't give it any command. So we need to have this little USB-C connector to be able to talk to the unit and tell it, I want to change your upload speed. I want to look at the 108 analyzer's internal ozone pressure data, anything that we need to interact with it, we were no longer able to do. So I just replaced this component last week. Only to find that unfortunately, it's in a new generation of AQ light now. So I think we had gotten one just at the transition, and so I think they had written down in their notes that we had this new incarnation, but it was programmed for the new incarnation. We had the old one, so we're waiting now for them to give us a firmware update to get all the modules back up online. But fortunately, everything is being recorded on a little SD card, so the unit's running. And it's running well. We've looked at the data and it all looks fine. But we can't get it to communicate with a 2B portal. So challenges all the time. And then finally, Another challenge worth noting is the need for annual calibration, right? To ensure that these monitors are behaving as we expect them to and closely tethered to reality. And so normally with these things, you would send them back to the manufacturer, right? But we can't do that. We're running these things 24 hours a day, 7 days a week, 365 days a year. And we all know how long it takes to get things out of Skagway and then back to Skagway. So we can't really FedEx this down to Colorado and wait for, maybe 3 months for it to go through all of the motions to get back to us. So our solution is now in the works, but we've developed protocols using this 2B Tech 714 calibrator. That's this thing right here. So we can perform field calibrations on all those FEM modules, the O3, the NO, and the NO2. Barclay and I are also working on a solution to be able to calibrate all of the little NO2 sensors in the PAMs and in the light. And I'm actually really proud of this. I'll show you guys this. These are the sensors. This is the NO2 sensor, right? It's this little guy right here, and this sits in a box like this. And so we could just try to pipe in some calibrated NO2 gas and then have the monitor read it. But we tried this out and it doesn't work. So you really need to isolate this sensor to be able to calibrate it correctly. And Barclay, I think it was yesterday, was saying something about a calibration cup, and the light went off in my head, and I was like, hey, what about these little film canisters? And so I've got this funny little thing that will fit right down over this sensor and then glom on there. And then now I can plug this into my outlet from my 714 calibrator, and I can feed it some gas so that it's able to isolate that single sensor while the machine is open. So as I've been telling these guys, field work is 99% innovation. And that's what we've done here. So it's we're still in the early stages, right? I've done several calibrations on the AQ sync back here successfully within the allowable tolerance that 2B is set out. And then the next step is to make this official and part of the array maintenance by revising our QAP to include this process. We're looking at possibly purchasing this Model 714 calibrator with some extra funds that we have. Right now we're borrowing the Park Services, which is great. We appreciate the opportunity to actually get this in the field and use it. So with that, I'm going to just dive right into the data, and then I'm going to hand it off to Barclay to talk to you guys a little bit more. Again, I appreciate your guys' time, so we're going to try to move through this real quick. This is something that I took from the DEC air quality team. They've got a little Quant AQ unit that's sitting out here on the corner of the Tribal Center, and they do quarterly data calls with all the partners that are involved in the project. And they do these heat maps to kind of show parameters over time. So what's going on here is we have 24 hours in the day. We've got 28 to 31 days in the month. Down along the bottom, we have 24-hour averages for each day. And then each one of these squares is color-coded for the entire year based on the lowest and the highest values. So we're not looking at the hottest and the coldest in just January, which is what we're looking at here. This is actually keyed to the rest of the year. But there's a really interesting thing that shows up here. This is PM 2.5, that fine particulate matter. And you're looking here around the 13th of January, you see that it gets really, really kind of hot, right? And you guys were here over the wintertime. What happened about the middle of January? Maren, you're off the hook. You weren't here.
I don't remember what happened yesterday.
Yeah. This is probably a bad time to recall some memories in the middle of the summertime. But from what I understand, Eric, really, really cold couple of days. So all of a sudden, everybody's firing up their Toyos and firing up their wood stoves and probably leaving their cars running a little longer so that the blocks don't freeze over. Although we don't deal with that so much here in Skagway. So it's cool to be able to see that represented in the data. And if we go and we look at the MET data, then we're going to see that temperature dip down during that period there and then come back up as you see it go back into the green. So we've got several of these heat maps for the whole year. And Barclay, do you mind jumping on at this point and walking us through what the data looks like and some of the awesome interpretation?
Sure, except I can't see your screen.
Oh, you can't see the screen. Am I not sharing? Oh my goodness, I haven't been sharing this whole time. Well, that's fun. Let's go there. Now you can see it.
Okay, there.
Man,
Okay, now, I mean, I was looking at the screen and I could see stuff, but then when I could see images and things, and then when this popped up, I couldn't see anything. It just, sort of faded into into the corner there.
I'll go ahead and advance to the next one for the full year PM 2.5.
Sure.
All right, here we go.
So there's a lot to digest here, but looking at the salient features, you can see, and is it going across? It's January, February, March. Next row, sort of restarting April, May, June. Next row, July, August, September, October, November, December. So as we go from, in the winter time, you have your really cold periods, but what you see is that there's just sort of intermittent hot spots, but you're sort of at a low in your regime. There are wood stoves, there are things going on, there are activities happening, but the PM doesn't really pick up until you start hitting the springtime. And then in particular, sort of your June, July, August time period where I think this is me assessing things based on data that I've seen, never having been to Skagway and only seeing pictures. But you can see sort of your midday peak, especially is that in July, you have midday, higher PM that I would associate with, cruise ships, everything else going on in and around the town. You move into the fall and then you see it taper off nicely, sort of into a more sort of background regime. And let's see. So we can go next slide. Can I advance them from here? No.
Yeah, you should be on NOx now.
Okay. And NOx. So NOx is the sum of nitrogen oxide and nitrogen dioxide. It's just a nice way of looking at them. NO2, nitrogen dioxide, is regulated under the National Ambient Air Quality Standards. But, we look at them combined because it really is the combined effort of both of them that affect ultimately air quality. So what you can see is, again, during the winter time, especially during the colder period, you can see a little bit more NOx, which is derived solely from combustion. In February, it's very low, and then we start to kick up in the springtime. But again, what you notice is once May starts, you really start to see the impact of, you have sort of clean at night, wee hours of the morning. There's more of it during the afternoon, the daytime and the afternoon, if I'm reading correctly. But you can see, again, sort of the same hot spots, especially June, July, August. During sort of midday, you have, high NOx emissions. In here somewhere is also a wildfire, which was, I think, August 7th in 2024. But again, you see sort of this seasonality, and you also can see sort of a day-night difference too. And then as we move into the fall and things have sort of calmed down in town, there's a clear reflection of that in the NOx data. And we'll go ozone. And NOx and ozone, there's very strong interplay between NOx and ozone. I won't get into the chemistry, but you look at this and it's like, oh geez, red is hot is bad. I wouldn't call the red in this case, sort of bad. You're seeing sort of background normal wintertime levels of ozone. What you see though is that throughout the days and the weeks of the month that you have more persistent ozone, so it's more stable. March is when you start to see a little bit more turnover and you have higher and lower values. This is sort of called the annual springtime ozone bloom. But what you start to see is actually ozone going away. So it's sort of anti-correlated with the NOx. So the more NOx you have, and you look at the June, July, August in particular, it looks like your ozone is going away and you have higher NOx. And that is a direct interplay on the chemistry. And, a joke that we will sometimes say is the quickest way to get rid of ozone is find some, very polluting cars and drive them around parks, and that'll get rid of your ozone problem. It's only a temporary fix because it's, like I said, it's the interplay of the chemistry. It's NO, which is emitted, reacts with ozone available to form NO2. So, and then once you form NO2, you start making ozone again, downwind. But it's very, the stark contrast between the NOx and NO2, it's also a good QC check too, that does this make sense intuitively what we're seeing? And yes, it does. And it also tells us about the dynamic, when we get into more of the analysis, not today, but when we dive deeper into the analysis, the interplay of ozone and NOx, spatial distributions, this all becomes very important to what is happening in Skagway. So,
and I'm just real quick, Berkeley, I'm going to toggle between the NOx and the ozone so they can see that kind of opposite. You can kind of see the hot spots and it, yeah.
I mean, especially like during the winter, you see sort of the cleaner NOx, the higher ozone. And then, I mean, like I don't know if it's just because it's in the middle of the screen, but like the July one in particular is a nice sort of summertime contrast. And all right. And then sure. X.
CO2.
CO2. And again, CO2 is interesting. Again, it's a marker of combustion, sort of idealized complete combustion, where carbon monoxide is incomplete combustion. But, a lot of biology is turned off. So during the winter time, you can see, there isn't, you can see some variability in the CO. You see some reds amongst the yellows, and that's localized combustion sources. But what you're not seeing is the impact of biology taking place. Then, you start your springtime transition, things start come to life. You start to see your drawdown from biology, but right in the middle of all of that, you have now sort of offset natural processes and are adding to it from anthropogenic processes. So you can nicely see exhaust. Ship exhaust, buses, trains, anything that is combusting, giving off CO2, you see it during the daytime there. And it's a pretty dramatic I mean, it's a pretty dramatic picture that it paints. And then again, as soon as we taper off in the fall, things start to, biology starts to go away and stop doing its thing. We see sort of the, dampening of the effect. But a very nice, the CO2 measurement provides a really nice seasonal effect. And it also tells us about anthropogenic influences in the region.
Wind speed.
And the wind speed. And the wind speed is actually a pretty interesting one, because, just being a coastal community, you automatically assume that your land sea breeze cycle is just gonna, your sort of normal cycle is gonna dominate. However, this tells a very different story where you have stronger winds at night, weaker winds during the day. What that means is that being in the valley, the topography, and you get the diurnal drainage that are overpowering what would be your typical day-night land sea breeze cycle. And I mean, it just like, I mean, Ruben sent this to me this morning and was surprised. And when he sent it and I looked at it too, I was surprised because I think you just assume, being a coastal environment, that you're just going to have that sort of typical land sea breeze where you have, sort of stronger, you'll have a stronger like onshore breeze during the daytime, because you get more surface heating over the land compared to the ocean. So, so, I mean, I'm not up there, but I wouldn't have expected this. And that's what I mean. There's been just this first year of data has been incredibly enlightening in terms of understanding, you think you understand processes. I've been doing this stuff a long time, and you think what you think you might see. But this is why we go out and do measurements too, because until you actually get out there and measure all of these things, you can only assume what is happening. And this has provided, this first year, and I want to give Ruben and his gang a huge kudos, because we actually have a remarkable data set to work with. And, it is the effort of the guys in the field, on the front line, keeping things alive, that have enabled us to put together a very informative and enlightening data set that has, I mean, if you just base it off the event that happened 2 days ago, it has proved its worth. But I think what we have learned throughout this process, and I'm kind of getting maybe a little ahead of the game here, but from these measurements, you think Skagway is sort of this remote, rural, quaint, coastal community, pristine. But when you actually look at the measurements, when you look at the levels of the NOx in particular and the levels of PM, it's like Skagway looks like a polluted urban center. You don't have enough fuel to ramp up the ozone to ozone exceedance levels, but it's because what is being sort of dumped in NOx wise is sort of tilting the ozone cooking scale a little bit. But it's one of these things I would have never expected things to look the way that they do. And it's not like things are horrible there by any means, but when you look at some of the trace gases and some of the key species, it's like, this looks like a polluted urban center. the levels of NOx that you see in Skagway are higher than you see at, I'm using a Park Service site, Carlsbad Caverns, which is right on the edge of the Permian Basin, which is the Wild West of oil and gas activity right now, and has high levels of NOx. Part of it is the topography. The topography and the meteorology coupled together allow for an enhancement and enrichment of things like NOx from cruise ship exhaust. So it's been a very, to me, we have a very powerful data set, the spatial distributions too. It's remarkable what we see at the water department versus the Alaska State site. So, and then putting it in this sort of heat map configuration really is a nice way of being able to sort of ingest these large volumes of data and, get a sort of good high level overview of what is happening in the area. And I hope my rambling has at least addressed a little bit of that.
I would say yes.
And I will try to speed things up a little bit here now. Because that is the last of the heat map. Okay, so moving on. So I actually have a slide that has the full time series data on there, but this is the way the first thing I do when I look at data is I just, time series plots of all the different species. And this was validated data through the end of January. And now we've got it, I have a plot now that unfortunately I didn't have time to get it in here, through the 16th. But you can really see a nice seasonal cycle when you plot the whole data setup. I wanted to, just point out, there's a lot of stuff going on. We have PM 2.5, PM10, NO, NO2, ozone, CO, and CO2. So all of the key players that go into understanding air quality where you're measuring. The first highlighted bar was a wildfire smoke episode in Skagway. And the second highlighted bar is to show contrast to the first highlighted bar, because that is the end of the season. And I have a zoom in of this, but if you just look quickly, just from scanning top to bottom, what you see is there's a lot of day, night, spiking on everything, and levels seem increased across the board because that was the first wildfire event that we had measured. In stark contrast to that, you go to, mid-October, it's like, and I have a zoom in that is better, but it's pretty remarkable what happens when cruise ship season ends. So next slides, please. And then it was getting too busy adding all of the different sites. So I put in the Alaska State site and the water department site. And what you can see is there's a general tracking of species, but there's some differences. In particular, it's almost easiest to notice the gradients in ozone during, if you look around sort of November, December, where you're not getting as much sort of up and down spiking, that you can see as you move from the docks to inland, your ozone increases because you have less NOx titrating it out. So you have localized effects, but you also seeing regional influences in the area. So there is great utility in being able to, do these spatial measurements that we are, currently conducting. And the data, the spatial data is of, very high value. Next slide, please. And this is what I wanted to show. This is my zoom in of when the season ends. And I mean, again, it's the same things. You have your PM 2.5, PM10, NO, NO2, ozone, CO, CO2. It's like a light switch has been thrown and everything just literally turns off. And ozone is the opposite, because if you look, it's anti-correlated with the NO and NO2. So when the NO and NO2 go away, your ozone actually recovers and stabilizes. And this is sort of background ozone for this time of the year. And again, your CO flatlines, your CO2 even flatline. It's like the town shut down. It's like everything just shut down for a couple days. It's pretty dramatic when you remove or you turn off the sources for a day, how things change. So I just, to me, this is one of the most dramatic, I didn't expect to see this, but how pronounced and dramatic it was when things ended. So next slide. And I'll try and move quickly now. So your black background made my black text disappear.
Oh, no.
That's supposed to say wildfire smoke event from August 7th, 2024. It's just and that was just a generic picture of like Canadian wildfires. That's all right. Keep going. There we go. So this is, up until this point, we had seen events throughout various parts of town, the train come down, stuff. But during this event on August 7th, smoke blanketed the town, and it's like, you don't want to say you're excited because things are you're excited because things are working, but not necessarily because the city, the town is blanketed in smoke. But this was sort of the first big test that demonstrated, the array in its form was functioning properly. And so next slide. I'll quickly go through this. This just is the fire and smoke map from Air Now. And again, this was from fires in Washington. I think they even went into Oregon too. And it was getting channeled right up the coast. There were other fires, I think, up north occurring at the same time. But it was the smoke maps that confirmed that it was actually from, coming from the south and not from the north or east. And again, you can see the lobe of the smoke plume, right over Skagway. And then where the smoke plume is not, it just happened to migrate up just past Skagway and stop. But this was a good opportunity as sort of a shakedown for the network too. So next slide, please. And this is just screenshots from the website. Because, as Ruben mentioned, Ruben and I and a few other folks, we're looking at this every day. What you see is, the AQI, and we got into the moderate range in the AQI. You have just, so the AQI calculation, it's a weighted longer term average. Beneath that is just the raw PM 2.5 data from which the AQI is derived. And so you can see, and ironically, because I've been doing this stuff since before like the AQI came out, that I actually know I need to know the concentrations in order to understand where I sit. So it's just kind of funny that, I have been adapting to the AQI because, I know 10 or 12 micrograms per cubic meter, which means nothing to most people, but that's the number for me. And like ozone, so, and then in contrast to the PM 2.5, the thing to note with wildfire smoke is you don't see the coarse fraction, so the PM10. There's a lot of activity up at the water department or near the water department, and Ruben has told me that is from like dirt roads, truck traffic type thing. So, you get a nice contrast between the PM 2.5 and PM 10. And next slide, please. And I like this just because, again, it shows your NO is your sort of fresh combustion. Your NO2 is not as fresh combustion. And then CO2 as the plume is being transported and aging, it is, you're adding CO2 to the mix. And so you see this sort of amplification in the CO2 across town. I won't get into the discrepancies between the NO2, but the red is the AQ sync. Everything else is the sensors. And what you see is that the sensors sort of capture events, but the reason why we have the sync is because the red line is the real NO2 measurement. Having this, we can then tether the sensors to this real robust measurement. And I'll just leave it at, sensor-based SO2 is a work in progress, and we're still working out some of the details and the best ways to sort of convey this information. So next slide, please. And I just wanted to give another quick highlight reel of the event that just happened over the weekend, which I think everybody was there to experience. I lifted this picture. It was actually from the NPR article that Ruben was quoted in. So it was nice I did a search and was able to find an NPR article that talked about everything that was going on in Skagway, Haines, and sort of the surrounding communities there. How, what is going on in sort of mid-North America is impacting southeastern Alaska. So next slide, please. And Laura Maybe, who works for Parks, is Laura in the?
Laura's here.
Oh, okay. So it was Laura's chat message that alerted me to the fact that this was going on. And so, I usually check it over the weekend, and I didn't check on Saturday. And then I went in, hopped on my laptop, and I was like, oh, there's a chat from Laura. Oh, geez. And then I looked at this, and I was like, I mean, it's like getting excited for the wrong reasons. It was like, oh my God. But again, sort of proving the utility of this. Um, and at this point in time, we've been operational for a year now. There's been a shakedown of things in the field. We feel good, comfortable with the data that is being generated. And then it's like, wow, we are in orange. That most everything is orange. We are approaching sort of the, unhealthy for everyone category. And, you see it at the higher elevation side, radio tower in town, and you have some mixes of yellow and I mean, it's mostly orange, but there's a few yellows mixed in there. The bottom line is that, you look, if you go to the next slide, if you look, oh, shoot, that's right, I forgot. I forgot. I added the map in.
You want to go to the next one after?
Yeah, well, I'll just quickly, yes. Yeah, I'll just quickly that the fires in, northeastern BC and northwestern Alberta, just being drawn all the way over. And, it's funny because there's actually whatever time I took this screenshot at, there was actually a little clear hole over Skagway where it doesn't look like there's smoke impacting it. But you can see that, the darker the color, the larger the smoke impact. But, that this was all being transported all down, through sort of the Panhandle area there. So next slide. So the point that I was going to make that I forgot that I had inserted that slide is that if you look at the PM, you have leading up to the event, you have a spatial distribution of PM where different things going on, different places in town. When this thing hits, everything responds, and you see this uniformity of response based on sort of where you're sitting in town too during this event, which gives us confidence in, again, further reinforces our confidence in the measurements that we're making. And, when something like this happens, it allows us to have confidence to be able to, disseminate the information to the community, knowing that, we are basing, what you are seeing is based on robust measurements. So the information that is being disseminated is of sound science. And like the other wildfire, you can see there's maybe a little bit more PM10 over here on the right-hand side. But again, the large fraction isn't really what's important. It's, the PM 2.5, and, these are, very high levels of PM 2.5. And I think I have one more slide, just again, showing some of the other gases. And we see this same on the left-hand side, it's CO2 and CO. So your markers of complete and incomplete combustion. And you see sort of the same sort of amplification again as the smoke plumes advect across town. You see sort of the day night, and it sort of cleans out at night from the winds, but then comes back during the daytime. And then it finally did get blown out. You can see that nicely with the CO. And then, the ozone, you can see an element of ozone. But what the NO and NO2 in particular tell you is that this is, some of the, they're fresh plumes, but they're somewhat aged too. We have other events that have higher NO and NO2 than we're actually seeing in the wildfire plumes. And I won't get into that, but again, what I've hoped to convey is that, the composite suite of measurements that have been put together, coupled, with the being able to get spatial and now elevational distributions, only lends more power to understand and assess the impacts of, local and distant sources on air quality in Skagway. And I think, oh, and because it's the black background, you can't see the text.
Ruben can fix that. I can do it. Watch me now.
But I mean, we can share, these are, right now, these are in order, sort of my favorite places to track wildfires. I sent Laura the fire map live, and I think I sent Ruben that one too. That's the one that was just a few slides back. That's sort of the latest, greatest composite satellite imagery, looking at PM being transported. So I like that one. And the Fire Smoke Canada, the first link is sort of information. The second one is also really good at looking at sort of the smoke forecasts. And then, I've been using, the AirNow again. I kind of like the visuals of the Fire Map Live the best right now. I feel like they've got the best aesthetics for what it's worth. So I'll stop there. I did not mean to ramble on for so long, but I appreciate everybody's time, and thank you for coming out and listening to us.
Thanks so much, Barkley. I always love hearing you talk about chemistry. Just you explain it so well. So, folks, I know we're past the top of the hour. I know we've all got things to do. Do we have any questions while we've got Barkley on the line? While we're all here together? Everybody's looking good. All right. Even though I didn't share my screen during this whole recording until Barkley got on, we do have some video editing magic, so we'll be able to superimpose the video and the audio over the slide set, advancing through for the video when it becomes public. We'll work on that as quick as we can so that folks who weren't able to attend will be able to look at this. And before we close, I just want to share something that came down the pipeline to me this afternoon. Second here, it looks like we are possibly looking at another air quality event coming through here. The National Weather Service and Department of Environmental Conservation is saying that smoke from British Columbia fires will start to impact the region later tonight. Mid and upper level winds will shift today, transporting smoke to the west over the coastal mountains. The greatest impact from the smoke will be for the communities of Skagway and Haines, Alaska. So Please use our portal. Please pay attention to what's happening with the ambient air quality outside. If you have air purifiers, just make sure that you've got good filters in them. Close your windows. I know it's hot outside, so it's the worst time, of course, to have a smoke event. But if you can create a safe airspace for yourself, it really helps. The Tribal Center, we have tested this. We plugged this up really nice, and we've got air purifiers here. If you need a safe airspace and you're not able to find one at home, please just get in touch with me or stop by the Tribal Center. We can offer you at least a clean airspace temporarily. There are some mitigation strategies, but it all depends on what's at hardware. I can show you that real quick too.
Wait, did that work? I'm just curious. I stole your screen.
You stole my screen.
Is it showing up?
It's not, because I'm beaming the PowerPoint up on the screen, but it is actually on Teams, so I'm going to move this over here. Now you've stolen my screen. Here you go.
Since you showed that, it's like this is the Fire Smoke Canada one. It is showing. It's got the town. This has the forecast down here, so it's got the 18th, 19th, and 20th. So it does show, impacting.
Oh, yeah. Yep. Right on top of us.
So, anyway, I didn't mean to. You pulled up the other one, so I was like, all right, I'll
No, that worked great. It's nice to know you can hijack a screen on Teams. This is our first time using Teams for these meetings, so hence the technical difficulties and the hijacking. I didn't know you were into piracy there, Barkley. At any rate, yeah, you can get a box fan and then one of those, like either a 1-inch or 4-inch MERV filter or a HEPA filter, whatever you would put in your furnace. You tape it to the box fan so that the air is pulling through the filter, and that will help to remove a lot of particulates out of your house. As long as you've got a good insulation and everything's nice and tight in your house, that should clear out the air for you to help create that clean airspace. And right now we're looking at some extra grant funds from this particular project to potentially offer seniors and other folks in the community who might have respiratory issues, actual air purifiers for their homes. So that we can be creating these safe air spaces for the folks who need it the most. So keep your eye out on that. Sarah and I just started talking about that the other day, just a couple of days ago. And so we're investigating on whether or not we can implement that. And the sooner the better, since we are in wildfire season. So be safe out there. Thanks so much again for coming out and listening to our chat and checking out all the hard work that we've done. Thanks so much to Colton and Eric for all of their endless work, banging their head against the wall, trying to figure out what the heck I'm trying to tell them to do in these air quality machines as I'm trying to figure out how to do it from the PDF and not having the machines in front of me. They're superstars, and they've really helped to create this really great data set that we have. And hopefully we will just keep this project rolling. All right. Thanks, everybody.
Thanks, everyone.
Have yourselves a good night. Thanks so much, Barkley. We appreciate you so much.
I appreciate you guys, and again, appreciate all the hard work you and your gang do. Keep this thing going.
Definitely. All righty.
All right.
Well, ta-ta. I'm gonna go ahead and stop this recording.
And
Bingo.
I will bid you farewell. Enjoy the rest of your evening.